just like we did at the end of our segment on form, this is the end of our segment on physical considerations. And we're going to look at a kind of synthesis of all of the issues we've been talking about on physical considerations. So the idea is, what is a building like if it's very sophisticated in addressing the rain and the wind and the geography and the soil conditions and the sun and the weather and the ecology, and if all of those become paramount in shaping a building, what kind of building does that produce? So that's what we're looking at today. As we did in the synthesis lecture on form, we're really just going to be looking at two buildings, and each of them extremely thorough when it deals with physical considerations, and seeing how that can make this very rich, very beautiful, very environmentally sensitive building. So we're going to start with a building by Herzog and Demeron, done in 1998. This one is in the Napa Valley in California, and it's for Dominus Winery. Now, Dominus is a French vintner, and they're an extremely fine winemaker. They're very, very famous in France. And they had always been very successful at winning all the wine competitions. Their wines were the best in the world. And then several decades ago, they began to lose out in those competitions to some of the wineries in the Napa Valley in California. And the fact was, those guys in California were dealing with a climate and with soil conditions that grew a certain kind of grape that was just superior to the grapes that Dominus could grow in France. So obviously that pissed them off pretty much. And their solution to that was to say, well, we're going to buy us a plot of ground in the Napa Valley in California where the soil is perfect, where the weather is perfect, and we're going to grow those perfect grapes, and we're going to show those California vintners that we can beat them in those competitions if we have the same raw materials that they have. So they bought this piece of land in the Napa Valley, and it's very precious land with just the perfect soil and just the perfect orientation. And they started initially by putting in the vineyard, and then eventually they built the winery to actually, produce the wine there. Now, this is not like a lot of wineries in the Napa Valley. A lot of wineries in the Napa Valley, they're all about tasting, they're all about visitors, they're all about sales. But this one is just about making wine. So you can't visit this building. It's not open to the public. It's not a sales device. In some ways, it's a kind of an industrial building. It's a building that's about making wine. So this is that plot of land they had that was so precious and had the perfect conditions. And they grew the vines first. It took years for them to mature. And then later they inserted the building right here to be a part of that wine-producing complex. Now, we're going to walk through this building really using the same criteria that we looked at in various lectures. So at the beginning, we were talking about how buildings should relate to the land. That's an important physical consideration. And that's here in spades in the Napa Valley. There's a row of hills that runs along this side of the valley, and there's a row of hills behind us on the other side of the valley. The Napa River is right behind us, and it runs linearly through the valley. And then there is this beautiful, flat, fertile valley in between. And that valley runs east and west. And the rows of vines are running east and west there so that the sun can hit each row of vines from the south. So they're orienting the vines just like we would orient a building to catch the sun and make those grapes perfect. And then the building was set in, long faces north and south, short faces on the east and west, running with that valley, just linearly with the rows of vines linearly through there. Now, the day I visited here, the owner, Christian Mouet, was there, and he showed me around a little bit. The architects were also there, Jacques Herzog and Pierre Demeron. And Christian Mouet was showing me around in these vineyards, and he would pick up a little cluster of grapes lovingly and tell me, oh, yes, we've had just the right amount of sun. Look how the color is just right here. And yeah, we had a rain 3 weeks ago, and that's why they're so full and so complete at this point. I mean, he knew the science of what makes a grape grow that way. And he realizes that what makes the grape grow just right for him is physical considerations. It's the sun. It's the how cold or how hot it is. It's how much rain you get. It's the kind of soil. And he described to me how he was an artist. He made wine, but he made beautiful wine. He made his wine out of physical considerations. He made it out of knowing how to deal with the soil and the sun and the rain and all of those things to make just the perfect wine. And when he wanted to make a building, he wanted that building to do the same thing. He wanted the architects to look at all of those physical considerations, take them into account, and to make something beautiful and artistic out of those very real physical considerations. So part of that was certainly laying the building very naturally into the landscape there. It's actually made of rocks that were collected from the soil there. And you don't, when you're doing agricultural work, you want to get the rocks out of the soil. So they're actually local rocks. The way they're laid up, they have a texture that's very similar to the hillsides behind them. This is actually quite a large building, but when I was trying to find it, the highway is kind of right behind us here. But I drove by several times and didn't even notice the building because it blends very easily and naturally in terms of texture and color with the landscape around it. And then it really becomes a part of the vineyard, just running the same direction as the vineyard and a natural part of it. Even some of the construction of the building, those rocks are held in gabion cages, these wire cages. The vines are held on wire armatures that run through the vineyards. So there's even a kind of similarity between the construction of how you make the vineyard and the construction of how you make the building. And there's just this beautiful kind of poetic empathy between the land and the larger landscape, the local landscape, and that long, lean, simple building lying in there. So that's how it relates to the land. The second talk we had in this segment, or third or somewhere around there, we talked about geography, topography, ecology. And we talked about how it's important to understand the soils and the rain and all of those kinds of issues. And here this is particularly important because in this case, this land was they bought it for the soil. The soil is very, very important. So you don't want to have any erosion. And even off of a building like this, if you collected the water and you had gutters and you had downspouts and you released the water and it started to erode the soil, that would be a horrible thing here. They needed to protect this very precious soil. So one thing they did was they put almost no impervious cover. Basically, there is no concrete. There's just the slab of the building. You can see here, there's a tiny little road that goes up to the sally port there. But for the most part, the entire building, every single bit of it, is just left with no impervious cover. And then when the rain falls, it's deposited on those gabions of rocks. And so the rain falls into the gabions and it splishes and splashes and splashes around until it makes a really fine mist by the time it gets here. And then it's deposited in that kind of mist on the soil there, creating no erosion at all. So again, very thoughtful in terms of geography, topography, ecology. They're even concerned about wildlife around here. One thing that is very common in vineyards is it attracts a lot of mice and a lot of snakes because they love to eat the grapes. And they were concerned that they did not want mice and snakes nesting in these gabions. So you can see there's a little denser weave of the gabion cages at the lower part, so varmints don't get in, and then it turns into a different kind of weave when it's higher than the varmints could get. So they're even thinking of the little critters in the ecology of this place. In another couple of the talks, we were looking at structure and materials, and we looked at bearing systems, and we looked at bending systems, and we looked at the traits of bearing walls and the kind of architecture that made, and the traits of bending system or frame systems and the kind of architecture that makes. Well, in this case, they're thinking that through extremely clearly. And you can see that in some areas, like this Sally Port, where the trucks are coming and going and making deliveries and pickups, you don't want much obstruction of that. So there are just a few columns. And you have a frame system that's made of steel. And then it has horizontal bar joists across there. And you can actually see the whole framing system above this ceiling that's made of a kind of wire mesh that just lets you sort of see up in there and see that frame system made out of steel. And that's appropriate for some parts of the building. Other parts of the building where they're, for instance, storing vats of wine, much more important to have the high thermal mass of these huge bearing walls made out of concrete. You don't need any views or any light or any openness. It's really industrial. It's just for holding those vats that contain the wine, or the kegs where they're fermenting the wine. So those areas have bearing walls. So they're bearing systems made out of concrete. They're bending systems or frame systems made out of steel. And all over the building, you can see that application. Here, they're bearing walls in the lower part here, which is full of kegs and the fermenting of the wine. And then up here, where it's actually offices, where they have their accountants and their salespeople and all of that, that needed to be much more open. They wanted views out and lots of breeze and air coming in. So you use a frame system on the upper level right there, and we're seeing that frame system on the upper floor here. But then where there are big kegs and vats of wine, there you absolutely do not want any apertures. You don't want any direct sun coming in. You don't need any views. So at that point, it's bearing wall made out of concrete with gabions on the outside, very heavy, solid, massive kind of structural system. So in this case, they're choosing the structural system very, very carefully to fit just what each need is. In another couple of talks, we were looking at the construction process and how that can become an important factor in shaping the building. In this case, because the vineyard was already there, and sometimes construction sites can be incredibly intrusive and disruptive, that couldn't happen here. Those vines are precious. That vineyard is precious. So we're trying to make the minimum impact with the construction process. And in order to do that, they kept a minimum amount of space around the building where they staged the construction. And I was actually there very shortly after they finished the building. And so they had, the site work and the foundation was very minimal. They just put a slab on grade, no elaborate machinery. Then they erected the structural system, the columns and beams in some areas. Then they made the enclosures, the thermal and moisture protection, in this case, glass curtain walls in parts of it. Then they added the systems and the finishes in the building so that it was a very controlled, very minimally intrusive construction process, using, for the most part, off-the-shelf materials that could be fabricated somewhere else, brought to the site, and just assembled on the site. So pretty much everything here is an off-the-shelf kind of manufactured material that's made somewhere else. Some very beautiful specific finishes, these huge sliding glass doors that are green and give a sense of the softness and the greenness. So they're making some pretty high finish elements, but always something that can be brought to the site and installed there and was minimally intrusive. Then toward the end of this segment on physical considerations, we were looking at climate response and the way a building can really be shaped and formed by the sun in particular. And wow, this building is so sophisticated in that regard. A lot of the circulation space in the building is outdoors. So that means that you're heating and air conditioning less space. So that's certainly economical in terms of energy consumption. This actually is kind of an outdoor conference room. When I was there, we had brunch out on a table out there, beautiful views out to the vineyard, nicely shaded, protected from the sun. So some of the functions of the office were actually outdoor functions, where you could have a meeting or you could have a conference that was outside as well as inside. And again, Napa Valley is pretty salubrious climate. It doesn't get terribly hot. It doesn't get terribly cold. So all of that makes a lot of sense. It is a building, as we saw, long faces north and south, short faces east and west. Pretty much all the fenestration on the north and south face, no east or west fenestration. Where you have those big openings on the south side, as we have here, or as we were seeing in that previous slide here, where that's all glass facing south. You have this deep horizontal sunshade that's happening here. And you even then have a kind of secondary sunshade that's dappling the light even on the corridor there. So a lot of sun control on that south side of the building, taking full advantage of high thermal mass. So the goal of Herzog and Demeron was to make this building have no air conditioning and no heating. They wanted to do the whole job passively. Christian Mouet said that he was just a little skeptical about that. This is millions of dollars worth of wine that's in this building. And wine needs to ferment at a very constant temperature. And in the old days, they put it in caves in the ground because the temperature was more stable underground. So Herzog and Demeron thought, well, we'll build a cave and we'll essentially make it underground and it'll be able to ferment at a constant temperature. Christian Mouet said, okay, you can try that as much as you want, but I want a backup heating and air conditioning system. So just in case it might not be exactly the right temperature, I can make it the right temperature. So that's pretty much what they did. But it turned out that they could do most of the job passively. And there's very little time of the year when they're using any kind of mechanical heating or air conditioning. So this would be one of those wine storage areas, all in these kegs. And these are thick concrete walls all the way around it. Those walls then have gabions on the outside of them, making them even thicker and higher thermal mass. So again, the sun shines on this during the day. It heats up that high thermal mass wall. And then when it gets cold at night, that heat is re-radiated back into that room, keeping it a more constant temperature. By the end of the night, maybe it's exhausted that heat, and it's ready to get recharged in the day that follows. So it's very, very constant temperature in those big wine storage areas. And then on the upper floor where it's offices, very different kind of environment. In that case, they're depending on breezes that go through here and the shading that's created either by the horizontal sun shading there or by the gabions themselves that let in this kind of delicate light that comes in. Now, in many ways, I think this is an incredibly beautiful building. It's a building that's so rooted in the fundamentals of weather and light and soils and land and breezes. And when you're there, you feel completely connected to nature and ecology. And because it's an agricultural function, it seems so beautiful and so appropriate. But it's an example of how you can comprehensively use physical considerations to really inspire a building. The second building I want us to look at is back in Australia again. This one is a home in really out in the boonies of Australia, probably 80 or 90 miles west of Sydney, out in pretty much the outback. The architect is Glenn Merck. It was done in 1994. Now, in this case, it's a very, very simple house. And it's in a landscape where there's a slope that's coming down the hill here. And there's just a little flat area right there. And the house is set on that little flat area, and then it dives on down. So the location of the house in the larger landscape was all about this little slightly flat area of land that occurred here. And then the house is strung along that little flat area like here. This is the living room, dining room, kitchen, 2 bedrooms. This is a little studio that also sometimes can be a carport if they are leaving their car and going somewhere else. So that's the kind of main house, little pool between, and the little carport studio area there. Again, long faces north and south, short faces east and west. There you can see the plan with just a simple living room, dining room, kitchen, bedroom and bathroom on one end, bedroom and bathroom on the other end, and this little interesting studio car kind of space over there. Now let's just think through, I mean, obviously it relates to the land beautifully. It's just slid right into that natural environment. And part of the goal of the house is just to be in nature. It's in a deep, deep eucalyptus forest, and it's adjacent to a big preserve of eucalyptus forest. And when you're in the house, it's almost like you're outside. It has these big glass doors that open up, and you can see right out to the outdoors. You stand there looking out into that eucalyptus forest. It's elevated slightly, so you really kind of feel like you're in the treetops when you're up there, but very much about being in the landscape and in the forest and connected with nature in that way. We talked about sort of geography, topography, ecology issues. It has a very minimal footprint on the ground, even less than the footprint of the building itself, just the smallest little connection to the ground, the very least impervious cover possible. It also is collecting all of the rainfall off of this monoslope roof into that gutter that then collects into these tanks. So all the rainfall on the roof is collected there, and that's used as the domestic water for the people who live here. That's what they flush their toilets with, and there's a filtration system that allows them to use it for drinking water and for cooking and for bathing and things like that. And then there also is water that comes off the hillside like this and actually goes into this pool. And that pool is not a swimming pool. That pool is a reservoir. And the idea is that the water comes off there, is filtered slightly in that gutter here, and then stored in that space. In a eucalyptus forest, you need fires periodically. That's the ecology of that environment. Actually, for them to germinate, they have a very thick seed pod, and unless there's a fire, that seed pod won't break open. So every couple of years, you need a fire to move through a eucalyptus forest, burn out the underbrush, break open the seed pods, and that just keeps the forest healthy. So because this is adjacent to a preserve, in that preserve, they just let the fires go. That's just the natural way these forests need to work. And it's really the craziness of a lot of our forest management in the United States, where we don't allow the fires, that then the underbrush gets thick, 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 and then when a fire comes, then the fire gets very, very, very hot enough to then burn the trees themselves. But in the eucalyptus forest here, if the fire comes through periodically and just burns out the underbrush, then you've got the trees don't get burned, they don't get damaged. Their seed pods burst open and it germinates the rest of the forest. So in this area where this house is, they refuse to protect houses from the fires. The fires are going to happen. So what the house does is it collects this water, and then that water is pumped up into sprinklers on the roof. And they're triggered by a thermal mechanism. So if it starts getting a fire and it gets really hot, then it trips that plumbing system and it completely inundates the house with a spray of water. And then that'll last as long as the fire is going. And then when the fire has burned out, then the thermal trip goes off and it gets turned off. So that reservoir is giving completely non-potable, non-filtered water that is available to inundate the house with water in the case of a fire. Again, responding to the actual ecology of this place where those fires need to happen, and the house needs to protect itself against those fires. So, responds very thoroughly to geography, topography, ecology. We had also a series of talks about structure and materials. Again, this is a house that thought that through very, very well. It's out freaking in the middle of nowhere, and there only are really dirt roads that you get to it. So you can't have big tower cranes, and you can't have concrete trucks, and you can't have 18-wheelers delivering big pieces of steel. Everything had to be pretty much brought in a pickup truck. So that restricted the structural system to being this very lightweight steel system. Very thin, tiny pieces of steel that all added up to create this bending system through the whole building. But each piece of steel was a size that two people could lift it and put it into the building. So that certainly was an important part of that structural system. And occasionally there's some bearing systems down here, making that kind of minimal foundation. But for the most part, it's bending systems, these thin, light systems. And actually, those little skinny pieces are in tension. And they're much more about where the wind wants to lift up that roof. Those things are in tension, keeping it from blowing the roof off. So every member you can see very precisely designed to its role in the structural system there. Then in terms of climate design, again, this building is extremely attuned to the climate, and it's a warm climate like we described earlier in Australia. And in that case, it's this big sheltering roof that's protecting all those windows from too much heat gain. It is creating cross ventilation everywhere so that you get every breeze taken into the house, and it opens up the house to really accept all those breezes. And you feel like you're in a shady spot in the forest. And it has that same coolness and naturalness, but comfort that comes from just that natural ventilation. Occasionally it gets cold here, not terribly cold, but it can get cold. There is one heating device in it, which is this big fireplace right here. And the fireplace is actually made of big sheets of steel. And it's like an old cast iron stove where once you get that fire going and you kind of toke it up, and then it heats up the steel in this case, or the cast iron in an old stove. It's a fantastic generator of heat, and that's right in the center of the house. Other than that, no heating device. It's just using the solar collection from the sun, and it's using that fireplace to heat the house in the wintertime. So again, this is an example of a very sophisticated building, taking into account all aspects of physical considerations and really making a kind of gentle ecological machine that works very much in conjunction with the land and the climate and the soils and the sun and the ecology of the place to really make a piece of architecture that resonates with nature. Okay, see you next time.